Okay, ladies and gentlemen, I need your attention. In this section, we need to be able to use logic and our postulates and theorems to understand what's true or what we can assume is true from a picture. Okay, so Addie, are all points shown here coplanar? Yes. Okay. Do you guys write true, false, or yes, no? Okay. Doesn't matter. No. All right. Cohen, BGI or collinear? BGI. No. D. It's definitely DGI. It looks like they could be, right?
No.
But is there a line through them?
When you put it at an angle, it
Okay. All right. AC and H are collinear. Zach. ACH collinear. Are they literally on a line? Okay, we're good. EG and AH are perpendicular. Adri.
True.
How do we know that?
Because there's a box.
Because there's that 90-degree angle mark, or we can call it a box. Okay. All right. Are these two angles a linear pair, Rhett? All right, we're switching to true and false. All right. Drew, what about AF and BD? Are they perpendicular? Okay, does it look like maybe they could be?
Yes.
I mean, it looks like it, but we don't have the information. We can't assume. Okay, it has to tell us. Okay, EG and BD, Jack, are they parallel?
Yes.
How do you know? Jack, how do you know?
Jack get it wrong.
And you can't say it looks like it. Okay. By looking at it, it looks like maybe, but we don't know. And if it doesn't say they're parallel, we can't assume that they are. Okay, this is the hard part about geometry, is not assuming. AF, Keegan and Ben. Turn your body to face the board. Turn, just stop. Jonah, are AF and BD coplanar? Yes. All the points are coplanar, so the line should be 2. Okay. EG and BD do not intersect. True or false? Tyler. Why? Okay, did we say that these are parallel?
No.
So are they gonna intersect?
Yeah, eventually. But we don't know if they are or aren't parallel. Yeah. Can't assume. We can't
assume. So we can't assume that they're parallel, and if we can't assume that they're parallel, non-parallel lines will intersect.
But you also can't assume that they're not.
Yeah, you can't assume that they're not parallel.
Yeah.
Yeah.
You can't assume anything, so it's no answer.
No, we can't assume that they're parallel. So if they're not parallel, they're going to intersect.
You can't assume.
Done.
So you can assume one way, but you can't assume the other.
We are never going to get through this lesson. 10 people cannot be talking at the same time. Let's just, okay. With the parallel versus non-parallel. If they're parallel, then we know that they will never intersect. Does it say that these two lines are parallel? No, then we assume that they're going to intersect eventually.
Does it say that they're not? Yeah, that's why we're confused. Because you said we can assume, so like how can we assume it's not?
Okay, things like right angles and parallel, we can't assume. Those things have to be given to us. So if they're not given to us, then we don't assume them. So it has to be the other way.
How are they given to us?
Okay. So like if the lines were parallel, and this is something that we're going to talk about, parallel lines get marked like that. And I think you guys have talked about that in algebra maybe. Okay, and we'll talk about that eventually. Okay. AF, what about AF and BD? Do they intersect?
Yes.
Yeah, they intersect at C. What about perpendicular EG and what? Whoa. Are these vertical angles? Are these vertical angles? Okay. Are these on this? Are these the same line? Okay. Cool. Go ahead and turn the page to this one right here. Stop talking. Like, just stop talking. It's not funny, Jonah. Because pretty soon you're gonna get a detention.
I wasn't talking. I actually wasn't. I was just laughing.
Is that any better?
Well, I was laughing about it.
Okay. First of all, right here, when it says a line perpendicular to a plane, I just want to talk about what that's going to look like. If we have a line perpendicular to a plane, then we're going to have an intersection, right? And it's going to look like this line's coming through. Anything perpendicular is always going to have that right angle mark, okay? If it doesn't have that right angle mark, if it doesn't say anything about something being a right angle, you cannot assume that it is, even though it looks like it. Okay?
Wait, it has the box though.
But
It has like the box thing.
She's talking about what it's not.
yeah, I'm saying that has to be there for us to assume that it's perpendicular. Jonah.
So would it be no conclusion since we don't know if it still could be?
So since I made the box, you know that this line is perpendicular to the plane.
And what if there's no box?
Then we can't assume that.
So it'd be no conclusion. But we also can't assume that.
So if it's not there, then it's not a right angle. Okay. Here we go. The 2-point postulate. Through any 2 points, there is exactly one line. And the other way around, a line point postulate. A line contains at least 2 points. Okay, that is something that we know. It's just a thing. It's true. It's a postulate. Okay. Remember, postulates we just accept for fact. You okay with that?
Yeah.
Do you have a question?
What's postulate? I can't remember.
The addition postulate.
Postulate is like a rule that we just accept to be true.
Is that in the very beginning that we did?
Yep. Postulate. A rule accepted without proof. Okay.
Got it.
The line intersection postulate. 2 lines intersect. And their intersection is 1 point. If 2 lines intersect, they intersect at exactly 1 point. If they don't intersect, then those lines are
Perpendicular.
parallel. Okay. Through any 3 non-collinear points, there exists 1 plane. A plane contains at least 3 non-collinear points. Okay. And then planes and lines. If 2 points lie in a plane, then the line through those 2 points is in the plane. Makes sense, right? If you can't handle it, on the home.
Wait, what is it again? I was distracted.
If we have 2 points in a plane, then the line that goes through those 2 points is also in the plane. Okay. And then 2 planes intersect in a line. 2 planes will intersect in a line. Okay. Now, we need to be able to use these postulates, okay? Eventually, we're going to use them to like prove things to be true. So maybe something looks like a right angle. So maybe we can write a proof to show that it is a right angle, okay? But we need to be able to understand these sets of postulates so that we can do that, okay? So I'm gonna hand out examples. Keep your book, keep your student journals open so that you can look at the names. All right, so I want you to look at these first two examples. Okay, and you have your student journal open. Where'd your examples go?
Steal it.
Look at number 1A and B, and I want you to decide which postulate this is, which postulate this is. Write it down.
Write it down.
Yes. I don't care about the 2.3.
Wait,
And we don't need to write it in if then.
No. Right.
wait, so where do you write it?
Just write the name of the postulate.
Where?
Right here. Okay. You'll know them. You'll know them. We'll use them a lot. Okay.
It's a plain line.
Okay, eyes up here. Emily, I have 2 lines that are doing what? Intersecting at a. Okay, what postulate is this describing? Okay, here I have 2 planes. What are they doing? They're intersecting. Okay, Ben, what is this postulate?
I would have to say that would be the plane intersection postulate.
There should be no talking. There should be no talking. Okay. Now, let's look at our next diagram. Okay. So first it says, use the diagram to write examples of the plane point postulate. Okay. Aiden, in your notes, will you please read the plane point postulate? Okay, thank you. A plane contains at least 3 non-collinear points. So, Aro, do you see a plane that has points? All right, which plane has points? Okay, plane P. So this plane's name is plane P. Okay, but you knew that C is one of the points you needed to tell me, right? Okay, so plane P contains what 3 non-collinear points? Okay, plane P, remember uppercase are the names for planes, lowercase, this N is line N, line M, plane Q, plane P. Question or not a question? Okay, this is point C because there's a dot next to it. Okay, so A, B, and C are non-collinear points all in plane P. Okay, all right, now I want somebody to read the plane line postulate. Paxton, how about you do that for me? Okay. If 2 points lie in a plane, then the line also lies in the plane. Okay. So Jonah, are there 2 points that a line is going through? Which points?
A and
M is not a point.
Oh, then try the second letter now.
B.
Okay. So,
Oh, the little, I was thinking like intersection. Not
okay.
point line.
Okay. So, okay, Paxton, will you read that for us again?
2 points lie in a plane, the line containing the lies in a plane.
Okay, so A and B are in plane P. Okay. So line N is in plane P. Okay. Since A and B lie in the plane, then the line that goes through them lie in the plane. Okay. Really, this section is about, can we follow the geometry rules to figure out what our picture is representing? Okay. So the next thing we're going to do is we're going to draw a picture. Okay. We're going to draw a picture. So flip it over to the back. We're going to draw TV intersecting PQ at W. So first of all, TV is a line segment. PQ is a line segment. Okay. Now I have this line segment with endpoints of T and V.
You draw this?
Yes. PQ is intersecting at point W and TW is congruent to WV. So W, Carson, what do we call W? If TW is congruent to WV. Bisector, midpoint, same things. And Stella, how do I signify that TW and WV are congruent?
That's a line.
Okay.
Be more specific. Okay, it's a line. What else could it be?
And then my segment PQ needs to go through W because PQ is intersecting TV at point W. Go ahead. It can be any way you want. The only thing that has to be the same as mine is that W is the midpoint and you have these little tick
I
marks.
think there's 2 lines.
There could be.
It doesn't matter.
Oh, I thought there was supposed to be.
They just have to be congruent.
If they're like 1 tick mark and 1 tick mark, those are congruent. That's a little excessive, but you could technically. Okay, last thing before we are done, I want you to look at this picture. Oh, we're gonna put a check mark on things that are true and an X on things that are not true. Okay, so let's see, A, B, and F. According to this picture, are they collinear? Check mark. They're on a line, people. They're on a line. EBS, EBD. That would be better. Do we have a line through them? Then we can't assume. Okay. Is AB perpendicular to plane S? Yes, we have this little cute red guy. But what about CD perpendicular to plane T?
No.
Do you see a little cute red box? Then we have no idea. AF intersects BC at point B.
Yes.
Your homework is the student journal page. So it like starts at the bottom of page 47 and then continues on to 48. That's your homework.
Time to go.
You know what I